The National Electrical Code, specifically Article 100, defines an outlet as a point on the wiring system at which current is taken to supply utilization equipment. To understand this definition, it's important to dissect its components. Firstly, a wiring system refers to the network of conductors, cables, and related components that distribute electrical power from the source, such as a service panel or distribution board, to various points throughout a building or structure. This system includes all the wires, conduits, boxes, and other hardware necessary to safely and reliably transmit electrical energy. Secondly, current refers to the flow of electrical charge through a conductor. It is the fundamental element that powers electrical devices and equipment. The amount of current flowing in a circuit is measured in amps. Thirdly, utilization equipment encompasses any device or appliance that consumes electrical energy to perform a specific function. This can include a wide range of items such as lighting fixtures, appliances, motors, heaters, and electronic devices. The key characteristic of utilization equipment is that it actively uses electrical power to accomplish a task. With these components defined, we can revisit the NEC definition of an outlet. It is a specific location within the wiring system where electrical current is drawn to power utilization equipment. This means that an outlet is not simply any point where electricity passes through. It is the designated spot where a device or appliance connects to the electrical system to receive power and perform its intended function. To further clarify the concept of an outlet, let's consider some examples. A standard electrical receptacle, also known as a wall socket, is a common type of outlet. It provides a convenient point of connection for plugging in lamps, appliances, and other portable devices. Each receptacle is designed to deliver a specific voltage and current rating to the connected equipment. A lighting fixture is another example of utilization equipment that is typically connected to an outlet. The outlet for a lighting fixture is the point where the fixture's wiring is joined to the building's electrical system, usually within a junction box. This connection provides the electrical power necessary to illuminate the light bulb or LED. A permanently installed appliance, such as a dishwasher or refrigerator, also requires an outlet. In this case, the outlet may be a dedicated circuit with a specific voltage and current rating to meet the appliance's power demands. The outlet is typically located behind the appliance and provides a secure and reliable connection to the electrical system. Now, let's address a common misconception about what constitutes an outlet. It is important to distinguish between devices that control or protect electrical circuits and devices that actually consume electrical power. A circuit breaker, for example, is a safety device that protects a circuit from overloads and short circuits. While current does flow through a circuit breaker, it is not an outlet because it does not supply power to utilization equipment. Its primary function is to interrupt the flow of current in the event of a fault. A switch is another device that controls the flow of electricity in a circuit. It is used to turn lights or other devices on and off. While a switch does interrupt or allow current to flow, it is not an outlet because it does not provide power to utilization equipment. Its purpose is to control the operation of a device connected to an outlet. In summary, an outlet is a specific point in the wiring system where current is taken to supply utilization equipment. It is the connection point for devices and appliances that consume electrical power to perform a function. Devices that control or protect electrical circuits, such as circuit breakers and switches, are not considered outlets because they do not supply power to utilization equipment. Understanding the NEC definition of an outlet is crucial for ensuring safe and compliant electrical installations. It helps electricians and homeowners alike to properly identify and install outlets in accordance with the electrical code, minimizing the risk of electrical hazards and ensuring the reliable operation of electrical equipment. To further illustrate the concept, let's consider a scenario involving a simple lighting circuit. Imagine a room with a single light fixture controlled by a wall switch. The circuit originates at the service panel, where a circuit breaker protects the circuit from overloads. From the circuit breaker, the wiring runs to the wall switch, which is used to turn the light on and off. Finally, the wiring continues to the light fixture, which provides illumination. In this scenario, only the point where the light fixture is connected to the wiring system is considered an outlet. The circuit breaker and the switch are not outlets because they do not supply power to utilization equipment. The light fixture, on the other hand, is utilization equipment because it consumes electrical energy to produce light. Therefore, the connection point of the light fixture is the only outlet in this circuit. It is important to note that the number of outlets in a room or building is a key factor in determining the overall electrical load and the required capacity of the electrical system. The NEC provides specific guidelines for the spacing and placement of outlets in various types of occupancies. These guidelines are designed to ensure that there are sufficient outlets to meet the needs of the occupants without overloading the electrical system. For example, the NEC specifies that in dwelling units, wall outlets should be installed so that no point along the wall line is more than 6 feet, or 1.8 meters, from an outlet. This requirement ensures that occupants have convenient access to electrical power without having to use extension cords, which can be a safety hazard. In addition to spacing requirements, the NEC also addresses the types of outlets that are permitted in different locations. For example, ground fault circuit interrupter, or GFCI, protected outlets are required in bathrooms, kitchens, and other areas where there is a high risk of electrical shock. GFCI outlets are designed to detect ground faults and quickly interrupt the flow of electricity, preventing serious injury. Understanding the NEC requirements for outlets is essential for anyone involved in electrical work, from licensed electricians to homeowners undertaking DIY projects. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with the electrical code. In conclusion, the NEC definition of an outlet is a precise and important concept in electrical engineering. It defines the point in the wiring system where current is taken to supply utilization equipment. While this definition may seem straightforward, it is often misunderstood. By understanding the key components of the definition and distinguishing between devices that control or protect electrical circuits and devices that consume electrical power, you can gain a clearer understanding of what constitutes an outlet. This knowledge is crucial for ensuring safe and compliant electrical installations. When working with electrical systems, always consult the NEC and other applicable codes and standards. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazard. Firstly, always turn off the power to the circuit you are working on at the service panel. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical systems in wet or damp conditions. Fifthly, if you are not comfortable working on electrical systems, hire a qualified electrician. By following these safety precautions, you can minimize the risk of electrical hazards and ensure that your electrical work is done safely and correctly. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is essential for anyone involved in electrical work to stay up to date on the latest NEC requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other sources. It is also available online through various subscription services. In addition to the NEC, there are other codes and standards that may apply to electrical installations in your area. These may include local building codes, state electrical codes, and utility company regulations. It is important to be familiar with all of the applicable codes and standards before undertaking any electrical work. Electrical inspections are typically required for new construction, renovations, and other electrical work. Electrical inspectors are responsible for ensuring that electrical installations comply with the NEC and other applicable codes and standards. They will inspect the wiring, outlets, and other electrical components to ensure that they are installed correctly and safely. If you are planning to undertake any electrical work, it is important to obtain the necessary permits and schedule an electrical inspection. This will help to ensure that your electrical installation is safe, reliable, and compliant with the electrical code. In summary, understanding the NEC definition of an outlet is just one aspect of electrical safety and compliance. It is important to be familiar with all of the applicable codes and standards, to follow safe work practices, and to consult with qualified professionals when necessary. By taking these steps, you can minimize the risk of electrical hazards and ensure that your electrical system is safe and reliable. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution and follow all safety precautions when working with electrical systems. If you are unsure about anything, consult with a qualified electrician.